And now we'll look at a more complicated problem with 3 variables, 3 equations. And in this problem, we're going to want to do something similar. We want to pick an equation we can easily modify so that we have equal and opposite coefficients. This middle one is the easiest one that I found. So I'm going to rewrite that twice and use it as my multiplying equation to get equal and opposite and eliminate, in this case, x. So if you take a look up here, negative 3 times the entire equation gives us negative 3x plus 3y minus 6z equals negative 15. And on this side, if I multiply by negative 2, I'll be able to eliminate my x. Adding, I get y minus 9z equals negative 25, and 3y minus 5z equals negative 9. And in this case, I can multiply this equation here by negative 3 to eliminate the y. That's 27 equals 75. Y's cancel. I get 22z equals 56. And if I multiply by negative 3 here, I'll get negative 3y plus 27z equals a 75, and the y's cancel. I get 22z equals 66, z equals 3. Okay, now it's a process of multiplying into the equations where I had 2 variables, including a z, and then from there up into with just one variable, or 2 values to find one variable. And now we want to take our value of z and plug it into either any of the equations we have 2 variables. In this case, I kind of like the y equation here, so I'm going to use y minus 9 times 3 equals negative 25. That's a negative 27, so if I add 27, I get 2. Y equals 2. And now I have y and z. I can choose any. I'm going to choose the equation with just the x. I get x minus 2 plus 6 equals 5. Negative 2 plus 6 is a 4, so if I subtract 4, I get x equals 1. And my solution then is 1 comma 2 comma 3. Alright, we're going to try to solve this system of equations here by substitution, and the method we'll use is to find an equation to rewrite in terms of a single variable. In this case, I choose the middle one. And then we're going to substitute that value of x into the top and the bottom, and then from there we're going to continue to do some substitution. So in this case, we get a 3y minus 2z plus 5 minus 2y minus 3z equals negative 10. I'm going to do some cleaning up here, combining terms and getting things on at the same side. So I'll subtract the 15 from here, and I'll be combining the 3y and the negative 2 and the 6z and the negative 3. So we get 3 minus 2 is y minus 9z equals negative 25. And over on this side, so in this case we can get y equals 9z minus 25. That'll be our substitute. Come over here, similar problem. We put 2, y minus 2z plus 5 plus y minus z equals 1. And now I'm going to gather my like terms and get the constant over the other side here. 2 plus 1 is 3y. Negative 4 minus 1 is, make this a little better, minus 5z equals negative 9. As I had from before, I'm going to plug in this y, doing some more substituting here. And this gives me 3 9z minus 25 minus the 5z equals negative 9. Combining my terms, I get 27 minus 5 is 22z. Adding 75 to both sides, I get equals 66. Divide by 22, z equals 3. Okay, now I can come over to this equation. 9 times 3 minus 25. That's 27 minus 25, so I get a y equals 2. And now that I know y and z, I can plug that into this equation that I've already rewritten. I put 2 there and a 3 here. I'll get 2 minus 6 plus 5. That's a 7 minus 6, so that's a 1. My x, y, and z then, my solution is 1, comma 2, comma 3. All right.